All right, welcome back. So currents move ocean water around, help to shape the geology of coasts. So do tides. Currents more kind of horizontal left-right, tides kind of in and out, also somewhat up and down. So tides are the generally twice daily rise and fall of sea level. Sometimes it only happens once in a certain location, one rise and fall, sometimes two rises and falls. Tidal ranges vary around the world. On average, a tide ranges from about 6 to 10 feet between high tide and low tide. Meaning, if you've ever been at the beach, at the ocean, in the morning, the water might be really close to the beach, whereas in the afternoon, it might be kind of further out. Later in the evening, it's kind of back in again. In the middle of the night, it's kind of far out. So it's this kind of rising and lowering of the sea, sometimes twice daily, that are tides. The world's largest tidal range, again, it's on average about 6 to 10 feet, but the largest one is 53.5 feet, and it occurs in the Bay of Fundy, Canada. They put in the fun in Fundy over there with that great range. So here is the Bay of Fundy up in between New Brunswick and Nova Scotia, Canada. So up here by Vermont, New Hampshire, Maine. So this is the Bay of Fundy up through here. You can see the further you go into this Bay of Fundy, the more the tide level ranges, get up to about 16 meters as you get closer in. So again, that's 50 plus feet. So here's an image just a couple hours just from one another where people are walking on dry land, and just a little while later, you're paddling through the ocean. So you can see the water's up to here, so already about 6 feet and change in a couple hours. So got to be careful. Again, other images. This is of the tide going out. You can see here are a couple people here, and here they are still here. So this wasn't like right away, but this is about an hour or so, one right after another. You can see how far the ocean has driven back tide-wise. The boat is now on the ground, so you got to wait for the water to come back in. So anyway, that's the Bay of Fundy. It's how tides work. So what causes them? Well, the sun and the moon. Now, what you see here is not to scale, not to size, not to distance, but we're looking at the gravitational pull of the sun and the moon. When those two things work together, the gravitational pull of the sun and the moon, when they work together, they create high tides and low tides, known as spring tides. When those things, the pull of gravity from the moon and the pull of gravity from the sun, are kind of in direction 90 degrees from one another, you get something called, neap tides, where you have lower high tides and higher low tides. If that's confusing, I'll explain it. But in general, the tides are due to the gravitational pull of the moon and the sun, more so the moon. So not only does gravity pull on the whole Earth, it pulls on every object, including water. So that's why you see kind of the water bulging in the direction of the gravitational pull. And again, the moon, even though it's much smaller than the sun, it's much closer than the sun. So the pull of gravity, the physics of how that works, is not only the mass of the object, the size of the object, but also distance. So even though the moon is much smaller than the sun, it's much closer. So it actually has a bigger gravitational pull on the ocean water, thus have a bigger influence on tide than the sun. The sun is much larger than the moon, but it's much further away. So its gravitational pull is actually much less than the moon. So spring tides, this is when you get the highest of high tides, you get the lowest of low tides. It has nothing to do with the season of spring, rather the term is derived from the concept of the tide springing forth. So the highest highs and the lowest lows occur twice each lunar month. So a lunar month is just the cycle of the moon from full moon back to full moon, which takes 28 days on average. And that's why the month is nicknamed the month. It's tied to lunar cycles. I don't know how sometimes the months they threw in 31 days, 30 days, 28 days, 27 days, 29 days, whatever they have. But in any case, spring tides, well, tides, high and low tides occur twice daily. The highest highs and the lowest lows occur twice a month, each lunar month, and it's associated with full moon and the new moon. Full moon and new moon, these are when the moon is lined up with the sun. And then you have neap tides, which are when you have the lowest high tides and you have the highest low tides. The origin of the word neap is completely a mystery. I researched it. It's a mystery. But neap tides occur 7 days after a spring tide. So you get a full moon, spring tide, 7 days later, neap tide. 7 days after that, you get a new moon, spring tide, 7 days later, neap tide. And these occur with the first and third quarter moons. This is when the moon looks half full. This is what some people refer to as a half moon. So third quarter and first quarter, this is what people come and refer to half moon. No, the moon is always half lit. It's just depending on what half you see. So in the full moon, it's only half lit, the side you're looking at. The other side of the full moon is dark. The new moon, you're looking at the dark side, and then the other side is the side that's lit up. So again, when you're looking at a full moon, when you're looking at the moon, it's always half lit. It's just how much of it you see. So please don't call third quarter and first quarter half moons. Third quarter, first quarter. So going from, let's say, new moon, then you get to a waxing crescent, first quarter, a waxing gibbous, full moon, and starts to shrink again, waning gibbous, third quarter, waning crescent, new moon. That cycle starts all over. That's 28-day cycle. From here to here, it's 7 days, 14 days, 21 days, 28 days. So again, the moon, even though it's smaller, being much closer, has a much bigger influence on tides. Before we do, let me give you another part of the super secret code. Again, it's all mathematically based, so take the answer that you have so far from the previous video, and then I want you to take the square root of that answer. All right, so whatever your answer is so far, take the square root of that answer. You got me? Whatever your answer is thus far, take the square root of that answer. We continue on. So what you're seeing here is from kind of mid-June to mid-July of 2021, depending on when you're watching this video, of a tidal forecast in Miami, Florida. So the highest points reflect high tides, the lowest points reflect low tides. You can see that given in a day, you can have 2 high tides and 2 low tides. So what we have here, so this tends to be the highest, looking at here, the highest high tides seem to be in this area. The lowest low tides also seem to be in this area. So that would indicate a spring tide here. Over here, I have the high tides tend to be the lowest, whereas the low tides here tend to be the highest. So over here, I have a neap tide area. And then again, coming back over here, I tend to have high tides that are high again and low tides that are low again, spring tide. But what you might notice is that these spring tide high tides are higher than the high tides of this spring tide. All right, stick with me on this one, all right? So why is one spring tide not as high as the other spring tide? In general, you have spring tides, the highest highs, lowest lows. It has to deal with, you guessed it, the moon again. So the moon, as it orbits around the Earth, it does so not in a circular pattern, but in an ellipse. And the Earth is not at the center of that ellipse. It's kind of shifted a little bit. It's kind of shifted a little bit in that ellipse. And so when the moon is closest to the Earth, we call that perigee. When the moon is furthest from the Earth, we call that apogee. Now this is kind of highly dramatized. It almost looks circular when you're dealing with such large distances like this, but it is a slightly squished oval orbit around the Earth. So when the moon is in perigee, it's closer, so it looks bigger. So if you've ever heard of a supermoon, it's because the moon is at perigee, it's closer. The opposite of that during apogee, when it's furthest away, is a micro moon. So it looks 14% bigger and 30% brighter during a supermoon. But that happens the whole time. Not only does the moon travel around the Earth in an elliptical pattern, the Earth travels around the sun in an elliptical pattern. When it's closest to the sun, it's called perihelion, and when it's furthest from the Earth, that's aphelion, or aphelion. That actually occurs in January. In January, the Earth is closest to the sun. So please don't ever say that during the summer it's hot because we're closer to the sun. No, the Earth is not closer to the sun. In fact, in July, we're actually further from the sun than in January. So how close or far away we are from the sun has nothing to do with the weather or the climate or the seasons. That's the tilt of the Earth. That's something completely different class too. But in any case, just something to think about. So perihelion or aphelion. So not only is the Earth closer or further away from the sun, the moon is also further or closer away from the Earth. So in January of 2021, this was kind of the setup. The Earth was closer, perihelion, and depending on which side of the Earth you're on, you're either seeing a new moon, which was in perigee, or a full moon in apogee. Well, here's what it was like in July, where Earth is furthest from the sun, aphelion. And if, depending on what side of the Earth you're on, if you have a full moon, it was in perigee, or if it was a new moon, it was in apogee. New moon, full moon. So let's put all that together, all right? Oh my gosh, and it's probably craziness right now. Okay, for example, let's look in this area, all right? When we know we had a spring tide, we have the highest highs and the lowest lows. Well, in June 24th, there was a full moon. Okay, so during spring tides, remember, it's either full moon or new moon. Okay, so I have a full moon, good. And what about the lunar cycle? Was it in perigee, closest, or apogee, furthest away? Well, around that time, the moon was in perigee, so I have a full moon, all right? So I have a full moon, which means a spring tide, and the moon was in apogee, or perigee, so closest to the Earth. So I have a larger spring tide because I have a full moon at perigee. The moon is closer, therefore greater gravitational pull, therefore higher high tides. Whereas looking kind of in July, around July 9th, we have a new moon, which we either need full moon or new moon for these spring tides. But the moon was in apogee. It was further away. So therefore, we have a smaller spring tide. So full moon or new moon is what we need for spring tides. But in June 24th, the moon was closer, so the highs was higher. And in mid-July, we had a new moon, which is good, but it was in apogee. So the high highs are a little bit lower than the previous spring tide. Isn't it fun? Look at that. Now we're talking about space. Here's another great example of tides. This is Mont Saint-Michel in northern France. During one part of the tide, you can drive and walk there. You better get there quick and leave quick, because at the other part of the tide, it's impossible to get there. That's fun. I would love to live there. Nope, you can't come here. Well, at least half the day. All right, we'll pause here. So that kind of wraps up our talk on tides. When we come back, we'll discuss waves. I'll see you back here in just a minute.